Um, yeah, I think like so the today's focus is basically around prompt engineering. So this is like so the prompt engineering in general um is quite important like when the LLMs came out. So we'll go into detail a bit to like what sort of prompt engineering sort of approaches are there. I mean, and like how we can sort of like um smartly get to what you want to build. Cool. And yeah, and like sort of figure out like how we can sort of like approach prompting in a much more structured way. So that's and also looking into a bit into OpenAI's playground and like how we can build like a custom GPT and how we can use that as well. But yeah, so it should be fairly straightforward. But feel free to ask questions in the chat, and I'll sort of check as I go, so that I can pick out certain questions. Yeah. As usual, we'll spend a bit of time to reflect and like use the chat to sort of answer this question, like what did you get done last week? So it's an important thing I do as well. Like if you can sort of spend a few minutes, couple of lines, if you can put like what did you get done last week? That would be quite yeah useful for everyone as well. But while you do that, I'll go ahead because we got a few slides to go through. So I want to like try and sort of go to the demo as planned. Um, so what we plan to do today, right? So I think like we'll sort of get um, understand what prompt engineering means, best practices, and types of prompt engineering. So different types of templates and use cases, and how you control the behavior of the LLMs. So obviously we're not going into like sort of jailbreaking LLMs yet, but that's an interesting area. Like for example, I'll sort of explain that at the end, like what I did at some point, like when LLMs came out. You could like jailbreak most of them, like you can remove guardrails. So you can sort of get another LLM to sort of like try and break the LLM to get it to do what you want to do. So there are things around that, but like this is predominantly in a safe environment, like what how we can sort of get LLMs to do what you want. And then we'll go into like OpenAI playground, like understand some of the features and explore some of the available ways that you can call OpenAI. There's response API, chat completion. You already use this already, but we'll sort of go into bit detail. Structured outputs, which is another area we want to touch upon. So basically, like how you can sort of get an expected output, like because LLMs tend to be quite let's say probabilistic, so it's very hard to get like like certain style, certain output. So how we can do that, and general common pitfalls and how we can handle that, and as usual the homework. Cool. So what is prompt engineering? So it could be an art as well as a science, because we're dealing with these probabilistic models. So that means like you can't necessarily always get what you want. But having said that, there are certain rules that you can follow, like best practices, for you to like have some level of confidence to get the answer that you want. And it has improved a lot in the last year or so, so that you can repeat it like repeatedly get the expected sort of style of answers. Maybe not the exact answer, but you can sort of tweak certain things and give a certain schema, and you can get the expected output from the LLM. So quite important to sort of like understand like some of the key concepts around prompt engineering is that prompts are instructions at the end of the day. It's not just, I mean, we tend to like casually like chat with ChatGPT and like sort of get things done. Like, because ChatGPT as a tool, in the back end, they do like prompt sort of like prompt enhancement. So if you ask something, question get enhanced in a way that it makes sense, and it will then go into the LLM to get answered. But in general, API might not do that. So you need to like make sure that you have the right kind of prompts in place. So the way you phrase things, how you arrange things, the structure, where you place certain instructions, that's gonna drastically change the answer. So it's quite important how you sort of define certain guidelines within the prompt. And yeah, and like think of prompting as programming as well. So in a way that you're instructing the LLM to behave in a certain way. So this will be quite important. Like if you connect certain external tools, like for example, if you connect an API to the LLM, like things like that. So you need to like make sure you define things in a structured way and a more methodical way. Um, yeah, Joy, feel free to ask the question. Yeah. So we'll sort of like go into detail in a bit, Joy. I think like basically like not just asking something, like more like giving sort of instructions. So I'll show some examples like how you can do this
Okay.
and like how not to do it. I think that that's gonna sort of explain it. Yeah. I mean, yeah, good question. Yeah.
Awesome. Thank you.
Cool. So I think like um so I'll show in a bit like what like how to like write like a good prompt, but it's important to understand like types of prompt that there can be. Like there's instructional prompts where you say, okay, summarize this report in 3 bullets, like which you tend to do most of the time with ChatGPT. Like you upload something, email or document, and you get these like summaries out. But there's also like other types like which are not common if you purely use ChatGPT, like few shot sort of prompting, which is basically you give a set of examples, like you say, do specific tasks, but also this is what good looks like, this is what bad looks like, and you give them the actual content and ask it to sort of ask the LLM to do something. So it could be like sort of analyzing some information and classifying something. So it's that's a use case. So then the chain of thought, which is basically asking it to think step by step. So this was quite important before reasoning models came into play, which is like the O3 model, the O series models in OpenAI. So before that, we had to ask it to think step by step. This was a bit of a hack we learned early on when the reasoning models are not there. So by doing so, we can ask, so the model will internally think through what needs to happen and then execute that. So that's where the reasoning sort of come into play. So in that way, it's enforced to like first think the approach it's going to take to execute um, the given task and then sort of do that. So that's been quite useful. And then the role-based method, which is quite common, especially with integrations where you need the LLM to do a specific task, and that specific task is replicating some human sort of behaviors. For example, if you want to be a financial analyst, if you want to be like a ESG specialist, if you want to be like a mathematician, physicist, whatever it is, like depending on the domain, you define certain rules. You say you are a financial analyst. This is your sort of lingo, and then you provide like define a persona for the LLM, and it will behave that way, and it will tap into the right kind of knowledge base within the LLM, and you can get much better results. So this is quite useful and got used heavily. And then there's also zero shot, which is simply saying you are not giving any examples. You directly ask the question, and this is where we'll sort of use um, ChatGPT, etc. This is the normal way that you'll use. Like the general query is like there are no examples. We just rely on the LLM's sort of memory and the trained data set. So these are not the only ways that you can prompt. There's also context engineering, which is slightly like a much more advanced concept of prompt engineering. But this is like more than sufficient for us, our use cases, and sort of get things going. But it's good to understand there are types of prompts here. So as I was going like explaining a bit more before, like what I mean by like a well thought out prompt. You generally like this is one type of a prompt, but like can be other scenarios. So you have to like if you are going down like to um, get a specific work done. Let's say you want to sort of give like a CSV file and some data sets and ask it to like analyze it rather than just asking it to analyze it. You can say, okay, you are a data scientist, and the task that you have to do is like explain like correlation and versus causation, and you ask it uh, to behave within certain constraint, like a certain number of words, the tone, and everything. You can define that, and format as well. If you want to have like a specific format, you can sort of provide that as well. So in that way, you're very explicit, like what you want, and you give structure and limit sort of ambiguity. So like if you define, let's say, just explain correlation, like what is correlation versus causation, it can go into like quite a few sort of examples. So I'll sort of show this like um yes, yes, Bipin, sorry, ask so Bipin, yeah, go ahead, yeah, I seem to hear you.
I think I lost you for a second.
Can you hear me now? Yeah, I think it's a very good question. So I think like I'll sort of quickly show this demo and like sort of go into that. Like the idea is like um so I mean if you take ChatGPT, it would have like a system prompt, like ask it to like something like be a helpful instructor and like be like a converse like a be have a friendly conversation, and the user may ask these type of questions and answer that. So that's a very generic way of behaving. And if you ask it to like be a specific data scientist, whatever, so it's gonna like tap into that specific knowledge base in the model. So that's instructed to go to that specific knowledge base rather than, so we are sort of restricting so LLM is like a zipped version of the world's knowledge, right? So you have different components that connected like a neural network. And so when you ask a general question, it can go anywhere. So it's like there are so many pathways. So if you ask it to say be a data scientist, it would have the data scientist specific lingo and the methods of thinking in a specific area of the neural network. So when you do that, it tend to like go in that sort of location and get the answers. That those are very specific and very much more focused, and that's the general sense behind this. And if you try to visualize how LLMs like a neural network get sort of activated when you ask a question, you can figure out, okay, in a general sense it might go in certain directions. In this situation it might go in like a specific direction where you would have the latent space, which is the where you have the model's weights relevant for that type of behavior, will be in that space. But I'll share some like sort of videos on this so you can sort of sort of understand this a better.
Thanks.
Cool. Um, this one I'm gonna try and so ask it. So this is now like so much information. Like I mean it's fine, but like it takes a bit of time for me to understand. So it has given some information. I mean it's not the best example, like, but just trying to show that what it looks like. So I'll go on another chat. I'm going to give that with instructions, and so in that way you can get something very specific. So but what I'm saying is like, given that you know like what you want to get, you can try and sort of define that within the prompt, and then you can use that within your use case. Previously it was pretty much free-flowing conversation, and it can be very long, short, depending on the use case. It's best to like define it as much as possible. But we can play around with these prompts to see like edge cases, etc. The idea here is that you try to like um, define the use case that you're getting at as much as possible. So that's going to constrain the answers and generally get a better result. But yeah. So general sense is that like similar to like coding, it's a incremental process. You can't just straight away get what you want, right? So I think you start with like even using ChatGPT, like ask you to generate a prompt with your sort of requirement, and then you use that to run tests, and then you observe the output, and then you refine the wording, like the constraint that you add, like the guidelines that you add. That is the general process, as similar to like software engineering, like any kind of engineering. It's an iterative process. Like straight away you can't get exactly what you want, and like it's very important that you work with like especially if it's like a domain specific problem, you need to sort of work with a domain specialist to fine tune the prompts, having the right kind of guideline, right kind of constraints. So after you test with a certain set of examples, you should be able to improve that and sort of keep sort of having multiple versions of it. So things like developing evals, like that is where it's really important, like similar to test cases within like software engineering, like test suits. In this case, like you'll have like evals defining your expected behavior for a given input, and this is why you sort of improve these prompts as you go. And this is like a well tried and tested method, and like a lot of people like now build like systems in place for these kind of workflows. Things like Langfuse is a good example for this. So there are like certain prompting techniques, right? So I think one of them is like it's like looking into like how do you sort of control behavior of LLM, right? So as I said earlier, you can like define a persona, like you can say you're an expert trainer, or you can say you're an expert data scientist, or you can define the behavior that you want it to sort of work, and then the controlling tone. So you can sort of get it to explain like I'm 5 years old, explain like I'm 10 years old. So depending on what you ask, it will sort of change the level of complexity and level of the way you explain something. So this is been commonly used, but can be used in quite a few areas. And you can also sort of enforce a format, like for example, like return valid JSON only, return in a specific markdown fashion. So you can sort of define this as well. So like for example, if you're using the output of LLM, you can have things in a certain structure and use that at the endpoint level, and then sort of build your sort of tool upon that. And also like it's quite useful, like use delimiters, like where you sort of keep boundaries. Like let's say if you're defining guidelines, let's say if you're defining like some sort of a chatbot, like to answer queries of a like a company, and when doing so, you can define boundaries. Like one section is for give me a second, says I'm offline. You guys can hear me, right? Cool. Okay, cool.
Yep.
Yeah. All right. So you can sort of define these boundaries. Like first part is the knowledge segment, and then you can have the certain restrictions that you can sort of define, like um, the behavior of the LLM. So things like that. So you can sort of have these logical segments, and then the LLM will also sort of like follow suit, like understanding this separation. And then you can sort of connect, like have like chain reasoning, as I said earlier, like think step by step, then summarize. You can sort of ask it to behave in a certain way, like even though directly ask it to like, okay, go and like build, like give me instructions to do something. So likewise, you can sort of ask the LLM to sort of define how the LLM should behave. So in doing so, it will perform better. And also like if you have certain like framework in your mind, how the problem needs to be solved, the LLM will also follow suit like that. So if it's a known problem that you know how to resolve, and you can sort of give these instructions on how to approach to solve the problem. So I mean, I'm like these steps you can go a bit deep. So I'll show like a resource that you can go into detail, like what each like step means, so that you have quite a few examples. So the idea about this like sessions as well, like try to like go broad as possible, and like the resources that I have like providing this section, you can sort of go in detail. So there are quite a few examples that you can look at, and at the end I'll show a bit more examples, but I think like when you start building using one of the agents, you'll see what this looks like. I think this piece we covered a bit, like the good prompting habits, like being specific and explicit, sort of breaking large tasks into sub prompts. Like so it's quite important, rather than giving like entire sort of asking like entire, let's say if you build an application, giving like the entire requirements document, it's not the best way to do it. Like best way to do it is like you'll give like step by step. You first build the logic piece, then add the database, and add the integration piece, build the front end. So likewise, you break it down into pieces and having sub prompts. And even like if it's not just building sort of application, like not using something like cursor, but using somewhere else, it's good to like break it down into like smaller prompts, and that's going to sort of give us more control over how the LLM works. And then obviously testing with different examples. And like similar to like what we looked at, like um, if we can sort of give what success looks like, the LLM would understand on how to generate that. And then you figure out like you run traces and figure out, okay, for a given input, we got these outputs and sort of iterate with time on how to improve the prompts. So these are like general sort of good habits when it comes to sort of building prompting. But yeah, I think so I want to sort of go into like the OpenAI's playground in a bit, but happy to take some questions right now. Yeah.
Hey, Aki, I have a question just really quickly. Like
Yeah.
when I was watching the video,
Yeah. Yeah, I
like
think
how do you
like
balance those two?
yeah, I think like it's more about costing. It's more about like other more than costing. I think the reason for breaking into like sub prompts is like we're not trying to confuse the LLM like to do asking to do so many things. So we like giving a very specific scope. So you break it down to sub prompts and you get a specific thing done, and then you go to the next level. So you sort of layer it on top of one another. So even if you like interact with ChatGPT, you'll see like if you try to give everything in one go, it will sort of like suffocate and like hallucinate, etc. So it's important like so far what I've seen like is that you try to like if you have something in mind, either you ask it to like first define the steps what it needs to do and then go one by one, or you define the steps like to get a specific task done, like let's say if you write like build an application or write some sort of a article, so you ask it to like think about the step that it needs to go through and then sort of go one by one. So it's a more of like getting the LLM to do what you want rather than costing angle. I think costing like might be similar in this case, I feel like. Yeah.
So I was just thinking about that. Thank
Yeah.
you.
Yeah, very valid point, 100%. I think like just to wrap that question up, I think like mostly you'll find like a very specific way you interact with it. Like what I found was like I started like putting everything together, didn't work out, so then I started like doing these layered prompts, and that tend to work, like especially with coding and building products. So in other use cases it might be different, but yeah. Yeah, Bibin, sorry, you got a question. Sorry. Very good question. I think like so I can give like sort of a midway answer for that. So the question is around like if you try to like rather than give the entire sort of prompt and you give step by step, and then in by doing so would the LLM miss the context? Is that the question? Okay, so I think like the to answer that, you definitely need the the fundamental context that is needed. But what you're breaking here is that the instruction piece, like you're asking to do a specific thing. So that rather than asking to do the entire thing in one go, you break it down into steps. But the foundational like context information that you provide, like that needs to be there. So if you have it at the top, it will be used across the entire chain, entire conversation. I mean, ChatGPT, for example, if you have at the top, it will use across the conversation. And the sub prompting, what I mean here is that basically in this context, is break the instructions down. Like you ask it to like do the first step, and after when it's finished, to the second step likewise. Like imagine you're writing like a research paper. So you write like let's say you first write the um what do you write? It depends on the person. Like you could be write the methodology section first, and then you go into the literature review. So you ask it to like do this step by step in a logical way. At the end, you create the entire thing. Like that's what I mean. Like so you'll have the context that is needed from the beginning. So you shouldn't like remove that in the process. Yeah, 100%. Yeah. I mean,
Okay.
like yeah, technically, I mean, um, the way that transformers work, it happens. I wouldn't say like okay, it knows 100%, but if you sort of so the instruction following LMs, like it's fine-tuned for it to understand instructions and sort of do that specific thing. So not the pure GPT models like without any instruction fine-tuning. So what that means is like it's sort of the they've been fine-tuned these models for to follow instructions. So whenever you give instruction, it figures out, okay, these are the action items I need to do, and then go and do that. So that's been fine-tuned in that way. So that's where the magic of LLMs come into play.
Thanks.
Cool. All right, so the next piece, before we go into this, I wonder, like, there's an example I can show very quickly, because I think spoke a lot about LLMs. One of the resources. So this is like a really interesting guide. This is on the slide deck as well. So this goes into all the so the prompt engineering principles, like things around LLM settings, sort of what each sort of parameter means, and also the types of prompting techniques we discussed, right? So like zero shot prompting, like there's nothing that's just like directly asking something. But I want to show something around it's like few shot prompting, which is basically you ask it in the example you have, this is awesome, this is bad, so you define like what is good and bad. So the LLM can sort of at the end generate like a rightful answer. Exactly. This chain of thought prompting, which is this is standard prompting where you have the question and answer, like give an example, and then you give another question and asking it to generate the next answer, but it got it wrong. So with chain of thought prompting, you say you sort of explain like the Roger started with 5 balls, 2 cans of 3 tennis balls, etc. So explain how it came to the answer, and then you have the answer, and that's an example. And then you give the question, and it is able to like extract the logic from this piece and then generate it. So these things are quite useful like 1 year ago, I would say, because that's how, but things have been improved a lot since then. But this is like a very fundamental type of prompting. But yeah, I mean, not going to like spend too much time on this piece, but like this is a really good resource that you can sort of go and read, and has quite a few examples on types of prompts. And yeah, I think we can spend a lot of time on this, like quite interesting stuff. But like next week, read this documentation. I should like after a couple of hours, you should be able to go through most of the prompting things, prompting focused information, meta prompting. I should be able to, sorry. This is from a different provider.
Oh, okay.
They
Thanks.
AI, but it's on the slide deck under resources.
Oh, lovely.
It's
Yep.
yeah. But yeah, the information is quite vast. So like, but I'm putting resources so we can spend a bit more time on your own to explore this space. But yeah, coming back to sort of where we were before. Sorry. Yeah, so I'm gonna try and like go through like OpenAI Playground. I think we sort of looked at this at some point when you want to get keys and like etc. But I want to like try and like go into sort of um, the chat interface on OpenAI Playground, which has the latest models, and you can sort of play around with it, and you can create your own GPT sort of endpoint, so that doing so you can create. So you don't have to like define a lot of sort of code and the prompts within the Python script. You can have that on the GPT side and create an endpoint. So that's one of the use cases of this playground. And also like just to test prompts to iterate through. It's a really good place. So how you like so you go to this endpoint like platform.openai.com, and you go to chat, and then so you'll have you have other information as well, but like we'll sort of cover them as we like in the next sessions. But today the focus is around the chat prompts, right? So this one, you can go to create, and it will give this sort of UI. So this is basically pretty much what you'll be able to sort of create like a sort of a chat interface and sort of play around with it. So I have slides as well, but I think like it would be a good place for us to like explore this directly, and then like maybe go back to the slides. So I'll sort of explain like different sort of sections that this has. So you have like overall, there are two options. There's responses and chat completion. So chat completions were the older version, which is in the past before responses came into play. Chat completion was the the default way that you wrote ChatGPT or any like endpoint focused software, and so you use that endpoint. Right now, the responses is like the upgraded version of it, and it can handle beyond text. It's multimodal, and you can have much more features around that. So if you're starting a new project, start with responses. If it is like a older build, you probably have like code around chat completion. So just know that that is the case, and yeah, we'll stick to responses for now. And so there are other sort of configuration here. You can select the model. So there are different types of models, right? You might have seen so many, like, I mean, ChatGPT is not the best with, okay, sorry, there's somebody. So ChatGPT is not the best when it comes to naming models. Quite annoying, like so many models about names. So yeah, so there are quite a few sort of older versions like that GPT 3.5, and like quite old. And there are so many versions of GPT 4, 4 Note, and there are yeah, I think like um, this the two main differences are like general. There's the O series, which is the reasoning models. So these models inherently has a reasoning step inbuilt, and then it takes a bit of time, but it is quite good for analytical kind of thinking. So I wouldn't reach too much into it, but like if you need like even like GPT-5, it's already like it's a thinking model. So if you need just like text generation, like I would go like something like GPT-4, like 4.1. So it says this is the smartest non-reasoning model. So there's some information here. So, but everything else, it is like reasoning models. It's going to take a bit of time. I mean, it depends on the use case. You select one and then stick by it. And if you select GPT 4.1, so in this, you don't have to sort of you wouldn't necessarily like reason. It doesn't take a lot of time. I can say what will happen. Let's say so. Yeah, so it's just a simple chat, and then you have these configurations here, right? So I mean, we can sort of figure out what that means. Um, so so you can control the number of tokens, and then there's like the temperature and top P. Like both of them are ways of controlling um, the variability of the results. So like if the temperature is low, it's going to be much more deterministic. If it is high, it's going to be quite creative. So this is quite important when you sort of, so if you change temperature, don't have to change top P. But yeah, I think you can sort of pick between the two, and then can reduce it. It's going to be quite deterministic. And if you set it to a high number, it will be quite variable, the answers, and you can also control the max number of tokens. And you have this sort of control over that. And so another thing is like the tool calling. So you can sort of connect quite a few tools. Like so these are quite available. Like if you remember ChatGPT, you'll have all these sort of features. If you click one of them, you can sort of add them. So you can enable web search, and you can sort of configure quite a lot here. With where do you want to like mimic the web search from, right? Like let's say um, the search is from United States, and you can set state, city, etc., and then search context size. So you can control a lot of things how the web search is going to be like. And yeah, and then like save that, and like say, I mean, I don't know like if this will work like uh, uh, now it's sort of triggering the web search function because we asked it to like have the web search function. Well, it is doing a search. I mean, I'll run through. And we also look at sort of other parameters. Okay, didn't get anything. Probably I need to figure something out. But I mean, just an example. So you can also like, apart from this, you can create like image generation. So that's another feature. You can sort of select a model and then sort of type of information. You can add that. You can sort of stack quite a few things. I mean, even though if web search doesn't work, let's say, I mean, like, yeah, need to check why web search is not working. I mean, just want to show that there could be tools, but like we need to test why it's not working. And also MCP servers as usual, so you can sort of have that. Okay, just a flower and like so you can add quite a few tools and sort of it will call the image generation tool here. And if you need code interpreter, you can do file search. So like if you have knowledge base, you can have MCP server, etc. I think you can also have variables in place, but this is not very commonly used. Like I'm not exactly sure like what are some of the best use cases for that, but it is there. And then quite important thing here is the system message. So if you need the like the behavior to be very specific, you can, this is where you sort of put like you're a data scientist, but you have very dark humor. So I'm gonna say explain how LLMs work. Maybe it's complex. Let's see. Yeah, it's try to be like try to have dark humor, but also there's quite a few errors in the output, which is quite interesting. I probably hit some sort of a, is this Russian? I don't know. It's interesting. Yeah, I probably hit some sort of a endpoint. I'm gonna like reset this thing, which is let's try. So I think earlier, I think it was probably because I had an image on the chat, so it probably messed up the context. But you can have like these kind of like behavioral structure within the system message, and you can have that. And also, if you need to have like some level of like user prompts here as well, so you can have that like if the conversation is already sort of going on, like if you need to have like a user prompt here, you can have that as well. So like any like information that seems like can be shared across the entire conversation should be within the system message, and you need to sort of add that there. So this is what I want to quickly touch upon, but I think the interesting thing is you could have sort of save this and it's gonna be like dark LLM, sorry, dark human data scientist. So after you publish it, you can use this to call the endpoint. So now what I'm going to do is like go to my cursor. I'm going to ask it, would you write a simple script? You guys can see the screen, right? Yeah, cool. Okay. Right. GPT file as you use that. I'm gonna get the an API key. We can see so it directly used what I provided, just installing as usual. So what I'm trying to do is like use the agent that we created on our side, and it's asking you to sort of use that. Let's see if it works. Yeah, so now you can see like as you can see here, let me see if I can make it. Yeah, so like similar to what we had before, like it's trying to be funny, and yeah, so so we don't have to like define this system prompt here. Like you can sort of control it from the dashboard, and then right now you just only have to provide like the question. So it'll sort of have the dark humor, whatever the system prompt we have defined. So we didn't have to define it here. So gonna like make it much more simpler and much more easy to control. Like if you have a very common endpoint, and also you can do the testing there as well. So is one way of doing this, and it's really good to have a practice around how the GPT models work, how do you interact with it, and then this is simply like how we can sort of call that endpoint, right? So So very simple script here, nothing complex, but you're using that specific agent that you created, the endpoint that you created, and then using that to sort of get a response. Yeah, and like this is what I want to cover with these, and these are mostly around like the rest of it is around most of what we covered. Let me see. Okay. So this is what I mentioned earlier, like the chat completion was the response API. There are two types of endpoints. So this is like the previous sort of version. So it's not recommended to use anymore. Response API is a much more structured way of getting it. And then like some of the features, right? So we looked at the model, you can pick the right model on the temperature, so creativity and consistency. But there are other sort of parameters that you can pass in. Response format, reasoning effort, and the verbose, like verbosity. Like, so if you need to be more details, you can sort of set that sort of parameter in play. And also like if you want to like store information, like to log the conversation data, you can sort of pass this information. Let me see if that is possible to view. Yeah. So if you look at this, so if you move to like a reasoning model or latest like GPT-5 model, you'll have like a new set of parameters. So you can set the type of format, either can be text or it can be like a JSON schema. So this is something quite important for us. Like I'm gonna like click that. So what this means is like you can define how the output that you're going to get going to look like. For example, if you need like a specific structured output, let's say like a JSON object, you can sort of define it using Pydantic sort of schema. So Pydantic is a Python library that helps you define the structure for a data set. So you can define the columns in the dataset and also the type of information that comes in the dataset. So the OpenAI also follow the same schema, and you can sort of have this guideline. So you can pick some examples here. So it may look like, so we can ask the LLM to like provide this, the output in this structure. So the name, and then the schema would have properties, authors, abstract, keywords, and it enforcing it needs to have title, authors, abstract, keywords. This is quite important. Like if you are building endpoints and getting sort of certain values back, let's say if you upload an invoice and asking the LLM to extract information, you need to have like the invoice number, the total, the value and different items. So you have a specific structure. You can't always expect that to be. So, but having this JSON schema, you can enforce the LLM to give that output. So this is, if you haven't used it before, this can be a bit complex topic, but know that you can enforce the LLM to generate outputs in a certain style. So you can set it like that, and you can sort of edit the JSON as you see fit, depending on the output. And you can set the reasoning effort, right? So it can be low, medium. It just takes the number of time, like the amount of time that's going to take to reason. So how that relates to the behavior is that it goes through quite a few loops. What it does is like when it comes to reasoning, LLM does is like come up with a solution, like steps to get to the final sort of goal, and then sort of do some activities, get some results, and sort of evaluate if the answers are good enough. If it is not good enough, it will try again. So this like reasoning effort is basically around like pushing it to the nth degree, try and like getting it to like do multiple iteration. And then verbosity, as I said, like if you want it to be short and long, the output that you get, because like when you're reasoning, like you can get like quite a few sort of reasoning steps as well, so you can reduce it if needed. And you can summarize it. The summary, you can have a summary or you can have detailed information. So likewise, there are other sort of parameters that you can set for this endpoint if you switch the model type. So GPT-5 is relatively like one of the latest models, and like and it does has reasoning inbuilt. And one of the important things is the JSON schema. I think like that's the takeaway from this specific slide, I would say. Let me see. Sorry. Okay. Yeah, so I think like use low temperatures for table apps. And then if you need analysis, like raise the reasoning effort to high, so you can sort of get it to like reason a lot more. So this is the piece around like getting the JSON sort of structured output, the one I showed you right now. So you can have like JSON format and you pass in like a JSON object and you can get the output in a certain structure. This is quite useful if you are sort of wiring this into a specific another endpoint and it's expecting this output in a certain style. So this is something to sort of like spend a bit of time this week to understand how this JSON structure works and like how we can use that. So I think this we did that with cursor right now, so we don't have to do that right now. This is the last slide before we go wrap it up. I'm also cautious of time as well. So these are like the common pitfalls and fixes. So if the output might not be JSON, so like you sort of come into issues, quite a few issues, because like you're expecting a JSON, sometimes it hallucinates and like have non-JSON object values written. So you can like enforce from response format to have a JSON object. So you do that, like LLM will always give a JSON object. And you can enforce it by adding a JSON schema if you need the right, if you want to enforce the right type of the column names, etc. And then the model will be too verbose, like quite a lot of content. So you can sort of set a word limit, so it will sort of reduce the output that you'll get. So if it for the same query you'll get like different kinds of answers all the time. So it's always better to reduce temperature, so it's going to be consistent. And you get like ambiguous roles, like different tone changes depending on the same question. Even if you ask the same question and even across the same conversation, it can change a lot. So especially with voice agents, this is a very important thing, because sometimes the voice agent tend to get enthusiastic, tend to get very angry, all kinds of issues I've seen. So to control that, you can, this is very quite evident in like voice agents because it tend to come out in the voice as well. So you can have like a structured sort of a definition to explain, okay, behave in this specific way, these are your sort of guidelines, and then you can sort of always expect it to behave in that way. And obviously hallucinations is a very big issue, so you can sort of add context and examples, and also you can plug in like a knowledge base, like a RAG system, so it can sort of reduce this hallucination impact. So yeah, this is the I mean, not everything, but like some of the common pitfalls and how do you sort of handle that when it comes to prompting. And you see them and then you learn how to handle this. So we sort of did this right now. So going in and getting the sort of example from the dashboard and sort of running it on our side using Python. So this is what we sort of looked at right now. To wrap it up, can do a quick Q&A and homework. Okay, I have missed the homework. So I need to add the homework piece and I'll sort of send it out. The idea here is to like use structured output and to use that within creating a GPT-based solution where you can use that for an actual problem that you may have, like at your work, like whether to summarize something, creating like generating something. So for actual use case, can you get like structured output and use that within an actual use case? So that's the sort of the expected sort of the homework, but I'll also update that. I may have deleted this slide. I need to check that. But I think we are at time beyond 5 minutes, but I want to like spend a bit of time answering questions. If you guys want to drop out, feel free to drop out, but I'll be staying a few more minutes to answer any questions you may have. Sorry, Vivi, I saying something, can't seem to hear.
Can you hear me now?
Yeah, I can hear. Yeah. Yeah, so the use case, I mean, two things, right? Like one is obviously you can create a like let's say if you're an organization that you are sort of want to have a consistent system prompt and have a specific set of tools that it needs to integrate, and you want to share that with like other sort of developers to use. So you can have this place rather than creating a separate service to host this endpoint, you can have that on the OpenAI side, build that and sort of expose as an endpoint, and everybody who'll use that will use that specific endpoint. Now you want to imagine you want to change something on that system prompt. You don't have to go individually change each user. You can change at the single point, and you can control how it's going to get how it's going to impact. Like so, if it's a change across the entire the organization, it's like a single source of truth, right, at the end of the day. So that's the most common use case and in production. But practically where I see this is a lot is around like building and experimenting your prompts and iterating and connecting certain other external MCP servers. You can sort of experiment here. So that's where the most like high value impact I've seen, like especially it's quite useful for non-technical people to like fine-tune prompts, like especially the domain expert. They want to like get like specific prompts done. So my previous workplace, like I had worked with quite a few analysts, like who have very specific financial knowledge. So they want to build prompts to analyze financial articles. To do that, they work with me and expose this like an agent for them. So they write quite a few prompts and like put examples in. And when the prompt is quite solid, they'll sort of provide it to me, and I'll put that in the LLM solution that I'm building, so that it's I don't have to like sort of go through the entire software life cycle to get a prompt in. So the prompting and the code can be separate by doing this. So that's the most important use case I see. Let me check. I think so. The parameters we had was so was there a parameter called velocity? Sorry, I know like this reasoning effort. Was there a velocity as well, or you mean verbosity? Verbosity, yeah. So it's basically like the amount of the text that it generate, right? So if you increase it, it's gonna cost you more. So like the output is gonna be a lot. So that's the thing. So uh, it like yeah, I think that's pretty much it. So if you have a high verbosity, like it will generate a lot of text, and it also could be impractical to use like with so much text. Like I think like high verbosity will be like if you're sort of debugging and doing some logging, etc. That's where the use case comes into play. Right. Yeah. Yeah. So I think like the next week or the week after, so we have vector databases. I think in that we are going into like tokens a lot more in detail. Maybe not too much around pricing, but like how tokens work and like so you understand like have a general sense. But definitely like we can sort of touch upon like costing as well a bit more. That's gonna be quite useful. Like in rule of thumb, Google stuff is quite cheap. Like Gemini is cheap, like is 1/10 of the cost, where OpenAI is a bit expensive, but yeah, it's the de facto sort of use case. And also there are specific use cases for different models. Like Gemini is good for like voice and like maybe images and stuff, where OpenAI is good for generic use cases, and for Claude is good for coding and sort of agents. So it depends. Rather than the costing, there are other dimensions to consider when you pick a model. Most of the time, yeah, cost per token, yeah. Even like multimodal is like cost per token, so that's how they sort of calculate. Sorry, multimodal means like video, like the different modalities like audio, video, those kind, not just text. Yeah, cool. Any other questions, guys? Yeah, for sure, for sure. Yeah, I'll set a link for that. Yes.
All right.
Yeah. Cool. Yeah, guys, I'll share the recording and the slides on the platform, and then yeah, and some resources to like sort of explore. I think like this shouldn't be just a top level thing. It needs to spend a bit of time. Like I think that's where you get the best out of this, and like go and struggle and sort of hit certain walls, and then like yeah, you'll be in a much better place. Like spending a bit of time on this. And yeah, as always, like shoot any questions you may have, and then like we can sort of go forward from there. Yeah, and sure, yeah, go ahead. Yeah, I think like generally like all the models I would say is like at the same level, like unless you define like bit more like I wouldn't recommend anything over another. Like obviously Gemini, OpenAI, Claude are at like the relatively good for this. But I think the way you prompt could be interesting here, because I think like for special data analysis, If you use like GPT-5, it's good because it does like have the agentic behavior. What that means is like rather than analyzing the data, it will sort of write, let's say, Python code and then execute that within that environment and then sort of get the results. It's not just analyzing the text, but like numbers as it is. It is writing the code to read the file and get the results and then like check what the results means and then adjust the code and then go on a loop. So I think that's the best way to do this, like when it comes to data analysis, because the LLMs are still text based, right? So because of
Yeah.
that, like, so it's sequential, so it doesn't have a sense of numbers yet. So the best way to do is like write the code, and in the sense like LLM will do it for you, write the code, run it and look at the results and then like sort of go on a bit of a loop to get to the best way. So that's one way of doing it. And also there are other ways, like you can sort of like connect other external tools. So how to like, so let's say if you want to create a model and run that, and that could be a separate sort of a tool like MCP server that you can connect to the LLM rather than the generic model itself. Yeah, it's a very interesting area. It's not being cracked yet 100%, so it's a very open area. There are things like Julius AI, which is trying to do this. It's like a platform that you can try. It's not a model, but it's a platform. So on its own, they're trying that. I would say, but yeah, I mean, I'll check for some resources as well, like that could be quite useful for this.
Thank you so much.
No worries.